Hi everyone. So in this session, we are going to discuss practice set 1 of combinatorics. In this practice set 1, there are total 30 Berkeley University questions. Okay, these are standard questions taken from Berkeley University. Okay, so let's discuss all these questions one by one. So let's start with the first question. So this is a very simple question. The question is asking how many ways you can rearrange the letters in Berkeley. Okay, so we want the permutations of this word, this Berkeley. Okay, so how many permutations are there for this word? What is the method number 1? Tell me, what is the method number 1? This is a very simple concept, that how many permutations are there. In this word, you can easily notice that there are 3 E's. Okay, so in this word, we have 3 E's. All the other letters, they are unique. Okay, so finally, how many letters are there total? You can see 1, 2, 3, 4, 5, 6, 7, 8. Total, you have 8 factorial divided by 3 factorial. This will be your answer, right? So very simple. This is your method number 1. Basically, you can apply the direct formula. Or what is the method number 2? That is very easy. Method number 2, and that is interesting. So see, what is the method number 2? In this word, you can see there are total 3 E's. Okay, we have total 3 E's. All the remaining things, all the remaining letters, they are unique. You can see B, R, K, L, Y. Okay, you have B, R, K, L, Y. So this is the method number 2. What is the method number 2? In the method number 2, see, first of all, in any permutation, how many positions are there? Tell me, in any permutation, total 8 positions are there, right? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. Okay, total 8 positions are there, right? Now, you tell me, how many positions we need for E? There are total 3 E. So how many positions we need for E? You can see there are total 8 positions. We have total 8 positions in any permutation. Whatever permutation you take, whatever arrangement you take, any arrangement you take, in any arrangement, there are total 8 positions. And how many positions we need for E? So there are 3 positions for E. So what you can do, from these 8 positions, you can select 3 position for E. Okay, you can select 3 position. You can select 3 position for E. For example, if I select these position, if I select this position, this position, this position, if I select these positions, now after selecting these 3 positions, after selecting these 3, how many ways I can put E's? Tell me, how many ways I can put E's? Means I select this position, this position, this position. After selecting these 3 positions, how many ways are there to put 3 E's? There is only one way. There is only one way. You have to put like this. So there is only one way. So I can easily say that this multiplied by 1, that is for E. Okay. After arranging all the E's, now all the E's you have arranged. Now you can notice how many ways for BRKLY. How many ways for BRKLY? That will be 5 factorial. These 5 factorial ways for remaining. The remaining letters, they can arrange in 5 factorial ways. Okay. The remaining letters, they can arrange in 5 factorial ways. So this is your final answer. If you solve it, then what is 8C3? What is that? That is 8 factorial divided by 3 factorial, 5 factorial, multiplied by 5 factorial. So if you see, this will cancel out, and finally your answer will be 8 factorial divided by 3 factorial. Did you get the same answer by method 2? See, method 2 also giving you the answer 8 factorial divided by 3 factorial, and method 1 also giving the same answer. So the same answer you are getting in both the situations, in both the methods. Which method do you like more? This is the direct formula, and this is, I can say, analytical method. This is analytical method. Now let me tell you, the second method is nice. What is the reason? The second method is nice because it can handle variations. If there is any variation, we can handle. Okay. See, this is a formula. If you remember this formula, then sometimes you can make mistake, or there will be some questions in which some variation will be there and you will not be able to solve it. But you can see, this is analytical method. If you understand this analytical method, then you can solve any question. Okay, so very simple. Now let's move on. Let's see this question number 2. So tell me the answer for this question number 2. There are total 72 students. We have total 72 students trying to get into 3 of my sections. Okay, basically like there is some professor is talking. Okay, so there is some professor is talking. Some professor is saying that there are 72 students trying to get into 3 of my sections, and there are 27, 20, 25 openings respectively. In these 3 sections, there are these many openings. Okay, how many ways are there for these students to enroll? How many ways are there for these students to enroll? Now you tell me, first of all, in this question, students are always distinct, right? Agree? Students, they will always be distinct. People cannot be same. They are definitely distinct, right? Yes or no? People cannot be same. Two people cannot be same. So students are definitely distinct. What about these 3 sections? These are identical or distinct? Tell me. These 3 sections, these are identical or distinct? Why these are distinct? Why these are distinct? Because you can see this word. Look at this word, respectively. See this word, you can focus. Basically, the question is saying that these many openings respectively in 3 sections. There are 3 sections. There are 3 sections. In these 3 sections, these many openings respectively. So basically, there are so using this word, you can easily notice that these 3 sections are distinct. So basically, you have 3 sections: S1, S2, S3. 3 sections. In this section, you have 27 opening. In this section, you have total 20. And in this section, you have total 25. And how many students are there? So remember, to this S1, we need to give 27 elements. To this S2, we need to give 20 elements. To this S3, we need to give 25 elements. And total, how many students are there? Total, how many students are there? Total 72. Okay. Is this summation, is this total equal to 72? Is this total equal to 72? Please tell me. Can I say 27 plus 20 plus 25? Is this total equal to 72? So yes, this is equal to 72, right? This is equal to 72. What is this case? Tell me, which case is this? We are distributing students. There are total 72 students. There are total 72 students. We are distributing 72 students into 3 sections, into 3 distinct sections. Into 3 distinct sections. Okay. See, there are 72 distinct students, and we want to distribute them into 3 distinct sections. So this is DODB template. Agree? This is your DODB template. Okay. Distinct student, distinct object, distinct boxes. This is your DODB template. This is the DODB template. Now there are 2 ways. In the DODB template, we know there are 2 ways. What is the method number 1? You have DODB template. This is your DODB template. What is DODB? DODB means distinct object, distinguishable object, distinguishable boxes. Okay. Different objects, different boxes. In this DODB template, you tell me what is the method number 1? What is the method number 1? So here you can notice that these are the boxes. Your boxes are, these are the boxes. Section S1, S2, S3. These are the boxes. And this is already given. We need 27 students here, 20 students here, 22 students here, 25 students here. Okay. So these are the boxes. You can see these are the boxes. Next, what are the objects? The objects are total 72. Okay. These are the 72 students. These are the objects. Now you can easily notice there is a formula for DODB. There is a formula, correct? So we have a direct formula for DODB template. And what is that? That is your n factorial divided by n1 factorial, n2 factorial, n3 factorial, where the summation is equal to what? Where the summation is equal to n, right? This is the condition. If you apply this formula, then this is the condition. Agree? This is the condition. This is the condition. If you want to apply this formula, this is the condition. So the answer will be 72 factorial divided by 27 factorial, 20 factorial, and 25 factorial. This will be the answer. Is this point clear? So this is your direct formula for DODB template. This DODB template has a direct formula. Okay, method 1. Method 1 is a direct formula you can apply. You can apply the direct formula because you can notice there are 3 sections: S1, S2, S3. S1 needs 27, S2 needs 20, S3 needs 25. Okay, and this is given to you because in this question we are using this word respectively. There are three sections. And these many openings are there. We have these many openings respectively. Okay, so very simple. We have these many openings respectively. So you can easily notice we have three sections, S1, S2, S3, and we want to distribute in this order. S1 should have 27, S2 should have 20, S3 should have 25. So, and the total is equal to 72. You can see the total is equal to N. So you can apply the direct formula and your answer will be 72 factorial divided by 27 factorial, 20 factorial, 25 factorial. Okay. And what is the method 2? Tell me. Method 2 is simple analytical method. Okay. Method 2, that is simple analytical method. See, S1 needs 27, S2 needs 20, and S3 needs 25, right? This is the distribution. Now you tell me what you should do. So what you can do, total 72 students are there. Total, these many students we have. So from these many students, what you can do, you can select 27 students. You can select 27 students. From these many students, you can select 27. What you can do? You can choose 27 and you can give to S1. Okay. So, and you can give to S1. Very simple. Then what you can do? From the remaining, you can select 20 students and you can give to S2. Agree? Yes or no? And then from the remaining, you can give 25 to S3. The remaining will be 25. And you can give them to S3. Okay, so this is your answer. So please tell me, did you understand both the methods? In the DODB template, we have two methods. Either you can apply the direct formula, or you can apply this analytical method. What we are doing, total 72 students are there. From these 72 students, we are choosing 27 and we are giving to S1. Then from the remaining students, we are choosing 20 students and we are giving to S2. And from the remaining students, we are choosing 25 and we are giving to S3. So these are the two methods. Tell me, which method do you like more? There is a direct formula method and there is a method number 2. This method number 2 is nice. Let me tell you, this is nice because this method can handle variations. In the GATE exam, if they give you some variation, then also this method can handle. Okay, so this is analytical method. Analytical methods are always nice. Remember this point. Analytical methods, they are always nice. And these formula methods, these are always boring. Okay, so let's see. Now you can easily notice this will give you the same answer. Remember, if you solve this equation, this I can say this is 72 C27 multiplied by what is this value? So basically, tell me what is this value? 72 minus 27. What is that? 45. From 45, you choose 20. Okay, multiplied by, and this is already 1. If you solve it, then you will again get the same answer. You will get this equation you will get. Okay, if you solve it, what you will get? 72 factorial divided by 27 factorial, 45 factorial multiplied by 45 factorial divided by 20 factorial and 25 factorial. Okay, so if you solve it, you will get the same answer. This will cancel out and you got your same equation. This same equation you got. Okay, so method number 1, method number 2. Both the method we have seen. Anyone has any doubt in this question? Let me know. So we have seen this question. Very simple. Let me see if anyone has any doubt. Please let me know. Anyone has any doubt in this question? We have total 72 students. We want to distribute into 3 sections. Okay, so this is DODB problem. This is DODB. Different students into different boxes. The boxes are sections. These sections are the boxes. And already it is given that these many openings respectively. This respectively word is actually important. This respectively word, this is actually important because this respectively word means that you have fixed ordering. Okay, in these sections, you have fixed ordering. Is this point clear? In these sections, we have fixed ordering because remember, there are 3 of my sections. So these 3 sections, let's assume these 3 sections are S1, S2, S3. Let's assume these three sections are S1, S2, S3. Now this word respectively is important. This respectively word is basically saying that in this order, these openings are there. Okay, is this point clear? In this order, S1, S2, S3, in this order, these openings are there. I hope this point is clear. So this respectively word is actually important. Okay, let's move on. Okay, so let's see. What about this question? This is another simple question, question number 3. How many different 3-letter initials contain A? Okay, we want how many different 3-letter initials contain A? They contain A. Contain A. So what is the best way here? Tell me, what is the best way to solve this question? That is the complement rule, right? That is the complement rule. So you can just apply the complement approach. Okay, what you can do? From total, you can remove the bad cases, right? I can say from total, you can remove the undesired cases. Okay, and what are the bad cases here? What are the bad cases here? Bad cases means do not contain A, not containing A. Okay, three letters word not containing A. Not containing A. So tell me, what is the total? What is the total? The total is simple, that is 26 power 3. These many. Okay, total is 26 power 3 minus not containing A, not containing A. So that is 25 power 3. Okay, so this is your answer. 26 power 3 minus 25 power 3. Remember this point, that total will be like this. The total is like this. You have 3, you want 3 letter. Okay, you want total 3 letters. You want total 3 letters. Then what you can do? Very simple. 3 letters you want, so 26, 26, 26. Okay, every position has 26 choices. Every position has total 26 choices. So because every position has 26 choices, so the total will be 26 power 3. And now we want not containing A. Okay, not containing A. Not containing A. So for that, what will happen? In this case, what will happen? Very simple. Every position has total 25 choices. Now every position has total 25 choices because you cannot use A. You cannot use A. So this will be like this. Now what you can do? From total, you can remove the bad cases. You can remove the undesired cases. So this will be your answer. Very simple question. Now let's see this question. Question number 4. How many license plates are there with 3 digits followed by 3 letters? Okay, 3 digit followed by 3 letters do not contain both the number 0, O. Do not contain both the number 0, O. It could have 0 or it could have O, but not both. Okay, means these, see, this is 0 and this is O. This is 0, this is like, for example, this is 0 and this is O. Now you tell me. Okay, so which case is undesired? You just tell me this point. Which case is undesired? Undesired case. Tell me which case is undesired? Let me know the undesired case. Where this is also there, this is also there. This is the undesired case. Remaining all are the desired cases. Like this case is desired. This case is also desired. And you can notice this case is also desired. So remember, these 3 cases are desired. These 3 cases are desired. The only undesired case is when both of them are there. So everything is given in the question. Please read the question. You can have O, you can have 0, but you should not have both. Okay. Do not containing both of them. So the undesired case is when both are there. The remaining cases are desired cases. All the remaining cases, these are desired cases. So tell me what will be the answer? The answer will be, again, you can apply the complement rule. Again, you apply the complement rule. Okay, again, you can apply the complement rule. What you can do? From total, you can remove. From total, you can remove when both 0, O are there. Agree? When both 0, O are there. Agree? Agree with me? When both 0, O are present. So very simple. Because I told you See, the question is saying that you want a license plate. You want this license plate. In this license plate, what you want? You want three digits followed by three digits, followed by three letters, Now the question is asking that these both 0, O, both of them should not be there. You can have O, that is fine. You can have 0, that is fine. But both should not be there. So the undesired case, when both are there, this is undesired case. This is undesired. So what you can do, you can apply the complement rule. So total minus when both are there. Now you tell me, what is the total? Please tell me, what is the total? That is, total is, remember, total means you want digit here, then later. Okay, this is the point. Digit, later. So for here you have 10 choices. For here 10 choices. For here 10 choices. 26 choices. 26 choices. So the total is 10 to the power 3 multiplied by 26 power 3. This is the total. Okay, minus when both are there, then what will happen? Tell me. When both are there, then what to do? Let's consider this case. Means you want this type of number plate. You want this type of number plate, digit, later, this type of number plate, and such that containing here you should have 0 and here you should have O. This is the given condition. Okay, what we want here you should have 0. Here you should have contain 0. And here you should have O. Contain O. Okay, so very simple. Now you tell me, containing 0, how many ways? These three positions, they contain 0. How many ways? Please tell me. These three positions contain 0. How many ways? Total minus not contain 0. Total minus not contain 0. Is this clear? Is this point clear? Total minus not contain 0. And for here, contain O. Contain O. See, this will be like this. And contain O, that will be total minus not contain O. So finally your answer will be what? You want this and you want this. So the answer will be this multiplied by this. Is this point clear? Please tell me. Is this point clear? See, very simple. We want those cases. We want those when 0 is also there and O is also there. This is what we want. I'm searching for this. That both 0 also there and O also there. Okay, 0 also there, O also there. So in this case, what should happen? In this case, I can say here you must have 0. Okay, at least 1 0 here. At least 1 0 here. And similarly, at least 1 O here. At least 1 O here. 1 O here. Okay, this is your O. So in this, very easily what you can do, this is what we want. And there is a complete separation, right? You don't need inclusion exclusion principle, right? There is a complete separation here. There is a complete separation here. Very simple. Here you must have at least 1 0. Here you must have at least 1 O. Okay, this also should happen. This also should happen. This also should happen. These two things should happen. This also should happen. This also should happen. Okay, so these two things should happen. Now, if you want this, at least 1 0 you want, containing 0 you want in these three positions, then very simple. Total minus when 0 is not there. Just focus on these three positions. There is a complete separation here. There is a complete separation. Okay, so you can see here in these three positions, I can say total minus not containing 0. In these three positions, I can say total minus not containing O. So your final answer will be what? This will be 10 to the power 3 minus 9 to the power 3 multiplied by 26 power 3 minus 25 power 3. So this value you remove. Remember, this value you remove from this total. So from this total, this is your total. Okay, from this you remove minus. This will be your answer. Please tell me, is this point clear? Is this question clear? This is a very nice question on complement rule. Do you agree with me? A very nice, very simple question on complement rule. Okay, so this is a good question. You can learn something new from this question. Some new approach you can learn from this question. Very simple question, very nice question. Okay, so I hope you understood. Just see, these are the undesired cases. So from total you remove the undesired cases. Okay, so very simple question. Now let's see the next question. Okay, so you can see this is the answer. You can see. Next, what is the question number 6? Let's solve it. Before we solve it, let me take the doubt in the previous question. Sir, can we solve it using inclusion exclusion principle? Sri, you can try. Okay, just try whatever you are thinking. Just try that and send in the private Telegram group. We will check it. You can tag me. Okay, so you just write your solution on the copy pen, take a photo, send in the private Telegram group, tag me. I will check it. Okay, so very simple. Now let's see this one. Question number 6. Tell me the answer for this question number 6. How will you prove it? How will you prove it? How are you going to prove it? Basically, we need to prove that this equation is equal to 6 power n. What comes to your mind when you see this? What comes to your mind when you see this? When you see this, what comes to your mind? See, whenever you see this type of equation, I'm telling you, whenever you see this type of equation, that nc0 x power 0 plus nc1 x power 1 plus nc2 x power 2 plus and so on, ncn x power n. What comes to your mind? What is coming to your mind when you see this? nc0 x power 0, nc1 x power 1 and so on, from nc0 to ncn, from nc0 to ncn. This is your binomial theorem. This is your binomial theorem. This is the binomial theorem, nothing else. Very simple. So here in this question also you have binomial theorem. Basically here x is equal to 5. In this question what is happening? Tell me. In this question what is happening? X is equal to 5. So just put x equal to 5. X is equal to 5. Now you can easily notice 1 plus 5 power n. What is that? That is equal to n power 0, 5 power 0 plus nc1 5 power 1 plus nc2 5 power 2 plus and so on, ncn 5 power n. So what that will be equal to? That will be equal to 6 power n. Agree or not? That will be equal to 6 power n. That is 6 power n. Isn't it simple? Please tell me. Let me know. Isn't it simple? So this will come to your mind very simple. The first thing that will come to your mind, that should come to your mind whenever you see this type of equation, please understand that whenever you see this type of equation like nc0 multiplied by x power 0, nc1 multiplied by x power 1, nc2 multiplied by x power 2, and so on, from nc0 to ncn x power n. This is your binomial theorem, and that is your 1 plus x power n. You already know this. Okay, we already know this. We know this binomial theorem, that x plus y power n, that is equal to nc0 x power 0 y power n, x power 0 y power n, nc1 x power 1 y power n minus 1, nc2 x power 2 y power n minus 2, and so on, ncn x power n y power 0. Okay, so this is the equation. So very simple. Is this point clear? And the proof also we have seen. This is the simple equation, and the proof also we have seen. Agree? This is the binomial theorem. In class we have seen the proof also. Everything we have seen in the class. Okay, so let's see this one. How many ways can I split 30 distinguishable students into 6 groups, each of size 5? Okay, so this is a very simple question. This type of question we have done in class. How many ways I can split 30 distinguishable students, okay, into 6 groups, each of size 5. You tell me one thing. So now, first of all, is this IODB template or DOIB? DODB. What template is this? First of all, I want to ask, this is DODB, DOIB, which template is this? Is this DOIB? Which template is this? You want to split these students into 6 groups, of size 5. Okay, some students are saying DOIB. This template is DOIB template. Okay, so is this DOIB template? First of all, 6 groups you want. Okay, you want total 6 groups. And whenever you are dividing some people into groups, you tell me one thing, like it's like in your class, sometimes you create 2 groups. Okay, these are labeled groups or unlabeled? In this question, when you read this question, these are labeled groups or unlabeled? Like, are these labeled groups, that group 1, group 2, group 3, something like that? Like, okay, Gryffindor, something like that, Hufflepuff, something like that. Are these labeled groups? No, these are not labeled groups. These are unlabeled. Simple, very simple, that you have 30 students and you want to split them into 6 groups. Okay, 6 groups you want to create. Okay, so these are unlabeled groups. These are completely unlabeled groups. So it's like these are G, 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 G. Okay, these are like this. Now, what you want? In this group also you want 5, here also 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 5. This distribution you want. You want this distribution. Very simple. Now, this is your DOIB template. Very good. This is your DOIB template, because in DOIB template, what we do? You have distinguishable object. These are the distinguishable student, and you are dividing them into identical boxes. It's like these are the rooms. Yes or no? These are the rooms in a hotel. You have the same rooms. Okay, these are the rooms in a hotel. You have the same rooms. You can call it R, and so on. Because please understand that in this question, when you read this question, you want 6 groups. So these are very simple. You can see these are unlabeled groups. These are unlabeled groups. These are unlabeled groups. Means it's simple like that. For example, you have A, B, C, D. These are the students, and you are splitting them into 2 groups. Split into 2 groups. 2 teams, split into 2 teams. It's like, okay, AB in one team and CD in one team. You tell me one thing. This and this, are they same? I'm asking, you have total 4 children. 4 children. You want to split them into 2 groups. Are these 2 same? Yes, of course, these 2 same. Here also AB together, CD together. Here also AB versus CD. And here also CD versus AB. Okay, AB versus CD, AB versus CD in both the situations. So these are same. This is what I'm saying, that these are unlabeled groups. So when you have unlabeled groups, you can call them G, 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 G. So this is your DOIB template. This is your distinguishable object, identical boxes. And what is the answer for this DOIB template when you have this scenario? Tell me, what is the answer? In the DOIB template. In the DOIB template, when you have G, G, or I can say, you can call it R, rooms, means identical rooms. Okay, and every room should have 5 students. Every room should have 5 students. Like you have total 30 students on a picnic. Total 30 students on a picnic, or in a haunted house, something like that. In a haunted house. This was our analogy, if you remember. Okay, 30 students on a picnic. They are going on a picnic, and you have same rooms. All are identical rooms. All are identical rooms. So these are identical rooms. So your answer will be what? Very simple. You can just apply this. That will be from 30. You select 5 and you put here. So see, there are 2 methods. Either you can apply the method number 1. What is the method number 1? You can apply like this. There are total 30 students. From these 30, you select 5 and you put them together. From the remaining, you select 5 and you put them together. From the remaining, and so on. You just keep doing like this. You just keep doing like this. From the remaining, select 5, put together. From the remaining, select 5, put them together. Okay, and so on. From the remaining, select 5, put them together. From the remaining, select 5, put them together. Is this the correct answer? In the DOIB template, is this the correct answer? In the DOIB template, remember the DOIB template. In the DOIB template, is this the correct answer? No, we have to divide by 6 factorial. We have to divide by 6 factorial. Is this point clear? We have to divide by 6 factorial. Because you have total, these are same. These are 5, 5, 5, 5. So we have to divide by 6 factorial. Because of these, we have to divide by 6 factorial. Is this point clear? If you solve it, if you simplify this this equation, if you simplify, what you are going to get? What you are going to get if you simplify this? Tell me, if you simplify this, what you are going to get? This equation, this complete equation, if you simplify, let me tell you, you will get this final answer. The answer that you will get will be 30 factorial divided by 5 factorial. Okay, so you can check. If you see, this will be like 5 factorial power 6 multiplied by 6 factorial. Is this point clear? See, so this way you will get, means if you simplify this 30C5 and so on, if you simplify this, then you will finally get 30 factorial divided by 5 factorial power 6 multiplied by 6 factorial. This you will get if you solve it. Is this point clear? Let me know. What is the answer that is given for this question? For this question, what is the answer that is given? Is this the answer given? 30 factorial divided by 5 factorial power 6. Is this answer given? Is this answer given? Tell me. Is this answer given? What is the answer given? Please tell me in the PDF. In the PDF, is this answer given? See, this answer you will get if you have different teams. See, if you have different teams, means if you have different teams, okay, if you have labeled groups, you can say that if you have labeled groups, you will get this. Is this point clear? Let me know. If you have labeled groups, then you are going to get this. When we have labeled groups, because you can check it out. Okay, let's assume that you have a labeled groups. Now this is your DODB template. Okay, because you have labeled groups. Now this is your DODB template. Now you tell me, 30 students are there and your groups are labeled. Now you tell me the answer. Just tell me the answer for this question. When you have groups are labeled, now you are very simple. From 30 students, you select 5 students, and to which label I will give? From 30 students, you select 5 students and give to label R1. Okay, for group R1. Agree? Yes or no? Is this point clear? Please tell me. From 30 students, you select 5 students and give to group R1. Give to this group R1, or I can say Gryffindor in the Harry Potter movie. From 30 students, select 5 students and give to group Gryffindor. Then from the remaining, again you select 5 and you give to for group R2. For group R2. From the remaining, you select 5 and you give to group for group R3. Like this you keep doing. What will happen? From 15C5, then 10C5, and then 5C5. Is this point clear? Now you can see this is same. These two are same. Please tell me, did you understand? So in the PDF, if this answer is given to you, then it simply means the professor is thinking that these are labeled groups. But by default, these are not labeled groups. When we divide some students, okay, when we divide some elements into, for example, when we split them into 2 groups, or we split them into 2 groups, then the groups are not labeled. Is this point clear? Okay, you can use your common sense, you can think about it. In the real life also, for example, you have total 6 children are there. You want to divide these 6 children into 2 groups. You want to create 2 groups, means this versus this. So they can play some football match. Okay, so you can see it's like ABC versus DEF. So these groups are not labeled. Okay, I hope this point is clear. I'm just telling you that in the PDF, if this answer is given, then it means they are considering labeled groups. And in the PDF, if you consider unlabeled groups, if you consider groups as unlabeled, then in this situation, answer will be this one. Okay, anyway, this is what you don't have to worry. You tell me, did you understand in the case of labeled, in the case of unlabeled? Like, for example, did you understand that 30 students, see 30 students, 6 groups, 30 students, 6 groups of 5 each. 5 each. Okay, this is the question. 6 groups of 5 each. This was your question. Now, in this question, did you understand that if you have labeled groups, then what will be the answer? If your groups are labeled, then this is a DODB problem. Then this is DODB problem. If your groups are labeled, then answer will be 3 factorial divided by 5 factorial power 6. And if your groups are unlabeled, then in this situation, your answer will be 30 factorial divided by 5 factorial power 6 multiplied by 6 factorial. Divided by 6 factorial. Okay, so this will be the answer. You need to understand both of them. Did you understand this one? When you have labeled groups, did you understand that case? And when you have unlabeled groups, did you understand that case? When you have unlabeled groups, then this is your DOIB template. If you understood both of them, that's fine. Okay, in the GATE exam, everything will be clear. In the GATE exam, there will be no ambiguity. You can check all the GATE exam questions, there is no ambiguity. So don't worry. From GATE exam point of view, they will mention it. They will give you everything very clearly. Okay, I just want to tell you that in the GATE exam, if they give you labeled group, you should understand that this will be the answer. And if they give you unlabeled group, you should understand that this will be the answer. Labeled groups, then DODB template. Unlabeled groups, then DOIB template. Okay, let's move on now. Tell me this question, question number 8. How many 5-digit numbers have strictly increasing digits? Strictly increasing digits. So this should happen. This should not happen. Okay, here you don't have strictly increasing. Here you don't have strictly increasing. A very nice variation also I will ask you, but before that, you tell me the answer for this. Increasing, and I also want to ask you this variation, decreasing. 2 variations I want to ask you, increasing and decreasing. So let's see the first one, strictly increasing. You tell me one thing, you want 5-digit number. You want 5-digit number where you have increasing digits. Can it contain 0? Simple question I'm asking, can it contain 0? Can it contain 0? A simple question I'm asking, can it contain 0? Can you give me a 5-digit number where you have strictly increasing digits which contains 0? Give me a very simple question I'm asking. Give a 5-digit. Give a 5-digit. Strictly increasing digits. Okay, remember, give a 5-digit number with strictly increasing digits. Strictly increasing digits containing 0. Containing 0. Give. So can you give? Just think about it. Can you create a 5-digit number? You must create a 5-digit number Okay, with strictly increasing digits, can it contain 0? The answer is not possible. The answer is that is not possible, right? That is not possible because it should have strictly increasing. It should have strictly increasing. So if you contain 0, then you have to put 0 where? In which position you have to put 0? If you contain 0, strictly increasing digits, so you have to put it here. This is the only place you can put, for example, something like this. For example, something like this. Okay. So now you can notice, is this 5 digit? Is this 5 digit? This is a 4 digit number. This is not a 5 digit number. This is a 4 digit number. This is not a 5 digit number. So this is what I'm saying, that it cannot contain 0. Can it contain 0? The answer is no. Okay. Now you tell me one more thing. Now you tell me the next thing, that is, so what to do? You want strictly increasing. So can any digit repeat? You want strictly increasing. So can any digit repeat? Is it possible some digit can repeat? It cannot repeat. So basically, how many digits you need? How many digits you need? Tell me. How many digits we need? How many digits we need? So total 5 digits we need. Agree with me? Because no digit can repeat. Repetition cannot happen. Digit cannot repeat because strictly increasing. You want strictly increasing. So repetition cannot happen. So we need total 5 digit we need. 5 distinct digits we need. Okay. And one more thing I want to ask, that is, if you have 5 distinct digits, if I give you 5 distinct digits, then how many numbers you can create? Okay. Okay. Once you have 5 digit number with specific set of 5 digits, set of 5 distinct digits, how many numbers you can create? Distinct digits. For example, if I give you these digits, for example, 3, 1, 2, 7, 9. If I give you these digits, then how many numbers you can create? Numbers we can create. Then how many numbers we can create? Only one, because we need strictly increasing. We need strictly increasing. So only one we can create. That is only one number we can create. And what will be that number? With these, what will be that number? If you have these, then what that number will be? That number will be 1, 2, 3, 7, 9. This is the only number that you can create. So final answer will be what? So you need, remember, very simple, you need 5 distinct digits. And once you have 5 distinct digits, only one number you can create. So what answer will be? And you cannot use 0. You cannot use 0. So finally, you can use these digits. You can use these digits. Okay, these digits we can use. From these we need 5 distinct digits. From these we need 5 distinct digits we need. 5 distinct we need. So that is 9C5. And once you have these, then only one number you can create. 5 distinct digits implies unique number you can create. Unique number you can create. Okay. So your final answer will be what? Your final answer will be, just see how many ways are there to select 5 distinct digits. How many ways are there? How many ways are there to select 5 distinct digits? Then you will get a unique number. So your answer will be 9C5. Or you can say 9C4. In the options, can they give you 9C4? In the options, can they give you 9C4? Yes. They can also give you 9C4. Because NCR equal to NCN minus R. NCR, that is equal to NCN minus R. Okay. So anyway, I hope this point is clear. Is this clear to everyone? This question. Complete analysis I have told you. Step by step. You can see strictly increasing you want. So it cannot contain 0. Second point. Strictly increasing you want. So digits cannot repeat. So you need 5 distinct digits. And also, once you have 5 distinct digits, for example, these, then unique number you can create. You can create unique number. So you can use these digits. You cannot use 0. From these, you can select 5 digits. Once you select 5 digits, distinct digits you select, then unique number you will get. So your answer will be how many numbers you can create. That will be how many ways are there to select 5 distinct digits from these 9. So the answer will be 9C5. That is equal to 9C4 because NC are equal to NC n minus R. So simple. And what about this variation now? What is the answer for this variation? Now you want decreasing, strictly decreasing. Can you use 0 now? Can we use 0 now? Can we use 0 now? Now can you use 0? The answer is yes. Yes, you can 0. You can use 0, right? For example, you can see, you can create this type of number. You can create 8, 5, 3, 2, 0. This number you can create. Okay, so very simple. Can you use 0? The answer is yes. We can use 0. But again, you tell me in this question also, how many distinct digits you need? Can digit repeat? You want strictly decreasing. Can digit repeat? No, digit cannot repeat. Okay, digit cannot repeat. So that is the reason. What is the final thing? These digits you can use. We can use. Okay, and how many you want from them? You want 5 distinct digits. You want 5 distinct digits. So that will be total 10 digits are there. From them, you want total 5 distinct digits. Once you have 5 distinct digits, unique number you will get. Unique number you will get. So your answer will be what? Your answer will be same as how many ways are there to select 5 distinct digits from this set. So your answer will be 10C5. Answer is going to be 10C5. Very simple. So all these variations, they can give you any variation. Can you handle? They can give you any variation, strictly decreasing, strictly increasing. They can also give you decreasing, increasing. Those also we will see. But in lectures, we have seen all these variations. Okay, in our lectures, we have seen every variation we have seen. If you remember, each and every variation that is possible, we have already seen. Everything is already there in our lectures. Now let's see this one. What about this question? How many permutations are there? We want permutations of these letters. How many permutations are there of these letters which contain ABC and also contain GFE? Which contain ABC and which also contain GFE? Okay, so this is the question. So tell me the answer. You contain means we want permutations of A, B, C, D, E, F, G. First of all, how many permutations are there? If I directly ask you, how many permutations are there? For example, if I remove this condition, then how many permutations are there? If I remove this condition, then the answer will be what? Then the answer is simple, that is 7 factorial. Okay, now you tell me, with this condition, we want those permutations which contain ABC and which contain GFE. So if you want those permutations, will this be one of the answer? Tell me. If you want those permutations, this type of permutations you want containing these. So tell me, will this be one of the answer? A, B, C, D, E, F, G. A, B, C, D, E, F, G. Will this be one of the answer? Will this be one of the answer? No, this will not be one of the answer. Okay, what can be the answer? For example, I can say this can be the answer. For example, I can say ABC, G, ABC, GFE. Okay, so for example, one answer can be like this: GFE, D, ABC. This can be the answer. Okay, very simple. Anyway, tell me the answer now for this question. So very simple. You have A, B, C, D, E, F, G, and what you want? You want substring. You want substring ABC. So this you want. And can you change their order? Can you change their order? For example, BAC, CAB, can you change their order? No, you cannot change because we want substring. So you cannot change their order. The same order will be there. And we want substring. And we want substring GFE. Okay, because you want this substring GFE, again, you can put it in a box. You can put this in a box and this order must be there. So what you can do, very simple. You can put ABC in a box, this D, and you can put GFE in a box. Okay, in a box. This you can put in a box. This you can put in a box. Very simple. Box, box. Now the answer will be 1, 2, 3. Answer will be 3 factorial. This will be your answer. Okay, very simple. Okay. So this is your answer. Now you tell me the next question. In this, there is another question in this. What is the answer for that one? Sorry. So where is the question? Yeah, this is the question. So in this, there is another question. What is that? The another question is like this. Containing ACB, CBE. This is another question. Containing AB, this one. Tell me the answer for this one. Okay, this is A, B, C, D. We want permutations. We want those permutations. Remember, we want those permutations we want in which you have this also and you have this also. How is it possible? Is it possible, first of all? Is it possible you can have this and this? Is it possible you can have ABC and CBE? Is it possible? Is it possible that you can have ACB? You can have ACB also. You can have ACB also, and you can have CBE also. Yes, that is possible. That is possible. Okay, that is possible. And the only way that is possible is you should have like this. You have ACB and you have like this. Now you can see. Okay, I hope you understood this. So this is what I'm saying, that you have this. So finally I can say containing ACBE. This question I can change. I can change this question. So this question is same as containing ACBE. This is your answer. Now the answer will be what? You put them in a box. You put them in a box. In this box you put them, and where are the remaining? The remaining people. The remaining people are like, for example, D, F, G. So the answer will be 1, 2, 3, 4. The answer will be 4 factorial. Answer will be 4 factorial. Okay, 4 factorial will be the answer. Now you tell me in the same question, if I change and if I say that ACB and CD, ACB and CD. Now you tell me, now what will be the answer? Now what is going to be the answer? I want ACB and CD. That is not even possible. That is not even possible. This, if you look at this, this is not even possible. Not possible. This is not possible. Because if you have ACB, then how can you have CD? Then how can you have CD? Then how can you have CD? So CD not possible. So this is not even possible that you have ACB and you have CD. That is not possible. So your answer will be 0. So here the answer will be 0. Because there is no permutation. There is no such permutation. So number of permutation is 0. Tell me the answer for this question. How many 5-digit numbers are there? You want 5-digit number which have increasing digit, which have digits in the increasing order. Increasing order, they can repeat also. They can repeat also. Increasing order, they can repeat also. What is this template? Do you remember what is this template? Which template is this? This is like non-decreasing order. Non-decreasing, non-increasing, this template. This non-decreasing, non-decreasing, non-increasing, okay, digits, non-increasing, non-decreasing digits, this template. Okay, so this template. What is this template? That template is same as your IODB template. That is your favorite IODB template. That is your favorite star bar. That is your favorite star bar. Agree? Okay, we have already seen this. So anyway, what is the answer here? So first of all, you can see that you want 5-digit increasing. You want them in the increasing order. Okay, you want total 5 digits. 5 digits you want, and you want them in the increasing order. First of all, if you want them in the increasing order, can you put 0? Can it contain 0? Simple question I'm asking. Can you contain 0? Just tell me this question first. Can it contain 0? Remember, you want increase, or I can say non-decreasing, or I can say increasing order. You want increasing order. This increasing order you want. If you want increasing order, can we contain 0? Can we contain 0? If you have 0, then where that will be? For example, if you have 0, then where that will be? You want increasing. If you have 0, something like this, then the 0 will be in the beginning places. Can I say? If you have 0, then 0 will be in the initial places. In the initial places, the 0 will be. And now, is this 5 digit? Is this a 5 digit number? This is a 3 digit number. This is a 3 digit number. This is not a 5 digit number. So can we contain 0? The answer is no. Can we contain 0? The answer is no. We cannot contain 0. We cannot contain 0. Is this point clear? So we cannot contain 0. Now, one thing I want to ask you. So this is clear. We cannot contain 0. So we can use these digits. 1, 2, 3, and so on. 9. These are what we can use. We can use them. We can use them. Now you tell me one thing. Actually, when you have non-decreasing order, or I can say when you have increasing order with repetition, increasing order with repetition, in this situation, what matters? In this situation, what matters? See, the only thing matters is how many these you are taking. See, means what I am saying. Please understand. Please understand. See, how many ones you are taking, how many twos you are taking, how many threes you are taking, how many nines you are taking. Only that matters, right? Like these are your boxes. These are your boxes. You can say these digits are your boxes. Agree with me? These are actually the boxes. These are actually the boxes. Okay, for example, if I don't take 1, if I take 2, 2, if I don't take 3, if I take, for example, 2, 4, and so on, if I keep taking 0, 0, 0, 0, and if I take 1, 9, now which number you will get? With this, which number you will get? Tell me. If you have this situation, which number you are going to get in this situation? So these are the boxes. These are the boxes. So which number you are going to get? You will get this number, 2, 2, 4, 4, 9. This is the number you are going to get. Is this point clear? And if you have this number, for example, if you have 2, 3, 5, 9, 8, 8, if you have this number, or maybe I can say 2, 3, 4, 9, 9. If you have this number, then what? Then what combination you will get? Then what combination you will get? Then you will get this combination, that there is no 1. I am not taking anyone. I am not taking anyone. There is 1, 2. There is 1, 3. There is 1, 4. And everything else is 0. And there are 2, 9. I hope this point is making sense. So can you notice this is your IODB template? This is your IODB template. Ultimately, what we want here. So this is your IODB template. I hope this point is clear. That, for example, 2, 2, 3, 3, 8. So very simple. This is your IODB template. This we have already seen in the lectures. But anyway, again, I'm telling you that this is your IODB template. And that is same your star bar. But here, who are the stars? Who are the bars? Tell me. Who are the boxes? Here, actually, these are the boxes. So please understand that here, these are the boxes. Here, these people are the boxes. All these are the boxes. Okay. So tell me, if you have 9 boxes, then how many bars? Total 8 bars. Total 8 boundaries. You need total 8 boundaries. 1, 2, 3, and so on. These are the boxes. So how many boundaries you need? Total you need 8 boundaries. Okay. You can see total you need 8 boundaries. Okay. And how many stars are there? How many stars are there? Total 5 digit we want. Total we want 5 digit. 5 digit. The summation should be equal to 5. Agree? The summation should be equal to 5. Agree or not? This summation should be equal to 5. The summation should be equal to 5. So I can say 5 stars we want. Summation should be equal to 5. So 5 stars. So finally, what is the answer now? So the answer will be, you have total 8 bars and you have total 5 stars. You got your answer And that answer is 13C5, or you can say 13C8. Will you remember that formula? Tell me one thing. We have seen this star bar problem, IODB template. In this IODB template, did I ever tell you to remember to by heart this formula? To by heart this formula. Did I tell you to by heart? No. Did we ever use it? Did we ever use this formula? We never use it. We never use it. We always use the star bar. And this gives you more intuition, right? That there are total 5 stars. 5 stars means total 5 chocolates are there. The Santa has total 5 chocolates, and there are total 9 children. And there are total 9 children. There are total 9 children. Okay, so very simple. So which method is giving you more intuition, and which method, I can say, in which way you don't have to by heart? See, star bar. This is, I think this should be your favorite now. We have seen so much in this star bar, so many variations. Each and every type of question we have seen, a lot of variations we have seen. I told you that this star bar, it is equivalent to total 7 problems, right? If you remember, 7 problems this star bar can solve. 7 problems, 7 different type of problems this star bar can solve. So this star bar, that's it. So this is your answer. Very simple. So we have never used this formula, and we will never use this formula. The main point, we will never by heart this formula. We have understood the concept. We have understood the star bar problem. Now you can solve any question, any variation, whatever they ask you. Now let me ask you one variation. If I ask you decreasing, then what will be the answer? If I ask you decreasing, for example, something like this. If I ask you decreasing, now what will be the answer? Now can you use 0? Simple question I am asking. Can you use 0 now? Can we use 0? Can we use 0? The answer is yes. Now you can use 0. Absolutely, you can use 0. What you can do? For example, you can create something like this, 98800. This you can create, there is no problem. Okay, so very simple. Can you use 0? The answer is yes. Yes, we can use 0. So finally, what will happen now? See, this will happen. We can use these digits to 9. These we can use. These we can use. Okay. And again, the same thing. So how many? These are your boxes. So these are your boxes. So tell me how many bars? So total 9 bars. And total how many stars? How many stars? Stars are total 5. There are total 5 stars. So your answer will be what? So the answer will be, that will be 14C5. Is this correct answer? Is this answer correct? Is this correct? Is it correct answer? Is it correct? No. What is the problem here? From this, you need to remove 1. Okay. From this one case, you have to remove. Only one case you have to remove. Only one case you have to remove. This case you have to remove. Only one case you have to remove. This case, this case, this case. Remove this case. Only one case you have to remove. This case you have to remove. So this is your correct answer. Okay. So I hope everything is clear. Right? I think everything is clear now. All these variations in the lectures also we have seen. Again, we have seen. Okay, let's see this. This is very interesting question. So let's see this. This is another question from the Berkeley University. Very nice question. A 7-digit phone number. This is the 7-digit phone number. When you can say this is memorable, this is memorable if first 3 digits that is same as these 3, or these 3 are same as these 3. Okay, then you can say it is memorable. In the real life also this happens. Agree with me? In the real life also, you will see companies have this type of phone number, something like this, like something like 9999090, something like this. They will repeat so that you can easily remember it. You can easily remember it. So something like this they will do. Anyway, so here this question is saying that 7-digit phone number is memorable if these 3 are equal to these 3, or these 3 are equal to these 3. How many memorable phone numbers are there? In this type of question, when you have this or this, what will come to your mind? What is the first thing that comes to your mind? What is the first method that comes to your mind? Either this happens or this happens. What is the first way, first method that will come to your mind? That is inclusion exclusion principle, right? It will come to your mind. That is inclusion exclusion principle. Principle of inclusion exclusion. Principle of inclusion exclusion. Or you can call it inclusion exclusion principle. Very simple. Principle of inclusion exclusion, or you can say inclusion exclusion principle. So the point is this will come to your mind. So let's solve it. So what we can say there are two, either this happens or this happens. Means either I can say D1, D2, D3, either that is equal to D4, D5, D6, or D1, D2, D3 that is equal to D5, D6, D7. You tell me what is common. You tell me what is common. What is common here? Means in this intersection, what will happen? Intersection means D1, D2, D3 that is equal to D4, D5, D6. And that is also equal to, D5, D6, D7. Agree with me? What is the intersection? Look at this intersection. This intersection. In this intersection, you have this also will happen, this also will happen. So D1, D2, D3 that is equal to D4, D5, D6. That is also equal to D5, D6, D7. What that means? What that means? It means D1 is same as D4. Can I say D1 is same as D4? Can I say D1 is same as D4? This D1 is same as D4, and this D4 is same as D5, and this D4 is same as D5. This D4 is same as D5. But D5 is same as D6. D5 is same as D6. And D5 is same as D2. D5 is same as D2. Okay, but D6 is same as D7. D6 is same as D7. And D7 is same as D3. So all are same. Isn't it? Very interesting, right? This is the reason I'm saying this is an interesting question. Basically, intersection will have intersection. In this intersection, you will have those numbers, this type of numbers you will have. A. This type of numbers you will have in the intersection. In the intersection, you will have this type of numbers. How many this type of numbers are there? How many this type of numbers are there? Total 10 this type of numbers are there, right? There are total this type of 10 phone numbers are there. Total 10 phone numbers are there. This type of. Will you consider this as a phone number? Will you consider this as a phone number? All zero. Will you consider this as a 7-digit phone number? Will you consider this as a 7-digit phone number? Yes, of course. Yes, of course. See, this is not a 7-digit integer. Is this 7-digit integer? This is not a 7-digit integer, but this is a phone number. This is a phone number. The point is, this is the point. This is a phone number. So I can say that you have 10 phone numbers in the intersection. Now you can solve this question, I think, very easily. Okay. What is this one? What is this one? What will be the answer for this one? Means, see, I'm asking, what is the answer for this one? Means this, how many phone numbers where D1, D2, D3, that is same as D4, D5, D6. How many this type of numbers are there? So you want total 7. Okay, these must be same as. Remember, whatever I put here, do I have any choice? Like, for example, once I put something here, now, do I have any choice here? Once I put anything here, see, here I can say 10 to the power 3. 10 to the power 3 choices. I can say there are total 10 to the power 3 choices. Once I put this here, do I have any choice here? There is only one choice, right? There is only one choice. You have to repeat it. There is only one choice. You have to repeat it. Okay. And here again, you have 10 choices. So here I can say this type of phone number, that will be 10 to the power 3 multiplied by 10. So these many phone numbers 4 numbers. Okay. Similarly, can you see? Similarly, I can say D5, D6, D7. D5, D6, D7 means here again, what will happen? D5, D6, D7. Now what will happen? Very simple. Here we have choices. Okay. In the first three position, we have choices. We have 10 to the power 3 choices. Here we can put anything. Here there are 10 choices. But again, you can notice once I fill it, once I put something here, once I put 101 here, now there is no choice here. There is only one choice here. So again, you will have these many. So your final answer will be what? So now you tell me what your final answer. Here you have 10 to the power 4. And here also you have 10 to the power 4. What the answer? The final answer. That will be 10 to the power 4 plus 10 to the power 4 minus 10. This will be your answer. That will be 2 multiplied by 10 to the power 4 minus 10. This is a nice question on inclusion exclusion principle. Simple, right? Very simple. Now let's see this one. Question number 12. How many 5-letter words have at least 2 consecutive letters are the same? When you see this type of question, what will come to your mind? What will come to your mind when you see this question? That 5-letter words, at least 2 consecutive letters. Complement rule will come to your mind, right? Complement rule will come to your mind. Very good. So let's use the complement rule. So what will happen? Complement rule means total minus undesired. Okay, total minus undesired. Okay, how many undesired cases are there? Tell me. How many undesired cases are there? Undesired means what? Undesired means what? No consecutively same. No consecutive same letters. No consecutive same letters. Agree? Agree or not? No consecutive same letters. You want at least 2 consecutive letters same. At least 2 consecutive letters must be same. So I can say total minus no consecutive letters same. No. All different. Is that undesired? Is this the correct answer? Is this the correct answer? Total minus all different. All different. Is this the correct answer? Total minus all different. Is this correct answer? Please tell me. This is wrong. This is a wrong. And in the GATE exam, if this question will come, many students will give this answer. In the GATE exam, if this question will come, then one option will be this. I guarantee you. I can give you guarantee that one case will be this. One option will be this. But this is wrong. Why this is wrong? Why this is wrong? Because this is desired. For example, this case is desired. For example, A, B, A, C, A. This case is desired, right? You can notice this is a desired case. This is a desired case. So we don't need all different. Do we need all different? We don't need all different. This is a desired case. Here you don't have consecutively same. In this you can notice you don't have consecutively same letters. You don't have. So this is a desired case. Remember, this is undesired case. For example, A, B, B, C, D. This is undesired. Okay. So I hope that is the sorry. Sorry, the question is asking at least 2 consecutive letters same. At least 2 consecutive letters same. So this is undesired. Okay. So this is actually undesired and this is desired. So this is actually undesired. And this is actually desired. Is this point clear? See, the question is asking at least 2 letters must be same. At least 2 letters must be same. At least 2 letters must be same. So I can say this is undesired, but this is desired. Okay. Anyway, so I hope you understood that this method is wrong. Total minus all different. This is wrong. I hope you understood. So now you tell me, total is very easy to find. What is the total? What is the total? That will be 26 power 5. That will be 26 power 5. That is very easy. So can you find the undesired cases? Undesired cases, can you find them? Undesired cases. That means consecutively you don't have same letters. No consecutive same letters. No consecutive same letters. This is interesting. No consecutive same letters. No consecutive same letters. So these are your 5 positions. These are your 5 positions. For the first position, how many choices you have? For the first position, how many choices you have? Anything can come. Anything can come. Anything can come. In the first position, anything can come. Let me put, for example, let me put y. Let me put y. Now you tell me, if I put y, now, how many choices for this one? No consecutive same. No consecutive same. So can I use y here? Can I use y here? Y I cannot use. I cannot use y here. So here, how many choices? Now you have 25 choices. Now you have 25 choices. Let me use, for example, let me use m. Now how many choices here? Now you cannot use m. You cannot use m, but you can use y. But you can use y, you can use z. Okay, you cannot use m. But this is fine, this is fine. Y is fine, z is fine. So again 25 choices. Again 25 choices. Interesting, right? It's interesting. Okay, again here 25 choices. Again here 25 choices. Again here 25 choices. So your answer will be what? Undesired cases. That is 26 multiplied by 25 power 4. So your final answer, you can say your final answer. Final answer will be what? That will be this minus 26 into 25 power 4. This will be your answer. Okay, let's move on. So these are some nice questions, some beautiful questions. Easy but beautiful. Some nice questions. Okay, let's move on. Let's solve this. How many integers between 1 to 1000 are divisible by 3 but not by 4? So how to do that? Let's assume these are divisible by 3. Let's assume these are divisible by 4. What you want, tell me? Which area you want? Let's call it area 1. Let's call it area 2. Let's call it area 3. And let's call it area, for example, let's assume, let me call it area X. Let me call it Y. Let me call it Z. Let me call it M. So what area you want? Which area you want? So the question is asking for which area? See, the question is asking X plus Y. This X comma Y, this area you want. Sorry, divisible by 3 but not by 4. Divisible by 3 but not by 4. You want X. You only want X. Divisible by 3 but not by 4. So how to find this X? Can I say this X is by 3? Can I say this X is by 3 minus intersection minus by 12? Yes or no? Can I say? Because by 3 means XY. By 3 means XY. By 3 means XY. So minus, what you will do? Minus Y. Minus Y. And what is Y? What is Y? Y is by 12. Very simple. Is this clear? So X is equal to XY. XY means by 3. XY means by 3. Minus Y. Y means intersection. Y means common. Means Y means divisible by 12. So your answer will be, in this question, your answer is going to be by 3 minus by 12. This is your answer. So how many by 3? By 3 is 1000 divided by 3 floor minus 1000 divided by 12 floor. This will be your answer. Is this point clear? Let me know. Simple question. Okay, by 3 minus by 12. This is your answer. You can check it out. Now let's see this question. This is your question number 14. I have 5 indistinguishable blue coins. So you have indistinguishable means identical, right? Identical. Okay. So you have blue coins, B, 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 B. 4 blue coins, identical. And 4 gold coins. 4 gold coins. 4 gold coins. How many ways I can stake them? Tell me. This is simple, means how many permutations you can create, right? This question is simply asking how many permutations of this. This question is simply asking permutations of BB, BB, GG, GG. Permutations of this. So this question is simply asking permutations of this, and that you can very easily find. How many permutations are there? BB, BB, GG, GG. So what is the method number 1? Tell me, what is the method number 1? The method number 1 is direct formula. The method number 1, that is direct formula, that is 8 factorial divided by 4 factorial, 4 factorial. This is your direct formula. And what is the method number 2? What is the method number 2? See, total how many positions are there? Total 8 positions. Method number 2 means total 8 positions. 1, 2, 3, 4, 5, 6, 7. So total 8 positions are there. I can say total 8 positions. So from these 8 positions, you select 4 positions for B. You select 4 positions. You select 4 positions. Okay, you select 4 positions for B. For B. If I select 4 positions for B, how many ways I can put B? I select 4 positions. Total 8 positions are there. In these 8 positions, I select 4 positions for B. How many ways I can put B? Only one way. Only one way. In the remaining, automatically who will go? In the remaining, automatically who will go? Gold will go. In the remaining, automatically gold will go. Or I can say 4C4, 4G. So your answer is 8C4. This is your answer. And actually, this is also same as 8C4. So your answer is 8C4. Very simple question. So you can see. Now let's move on. Let's see this question number 15. What is the coefficient of x power 7, y power 9 in the expansion of 2x minus 5y power 16? First of all, is this even possible? First of all, in this expansion, is this term possible? Is this term possible? So you can see here the power summation 7 plus 9. If you add the powers, 7 plus 9, that is equal to 16. Yes, this is actually possible. Okay, this is possible. So yes, I can say this is actually possible. In this term is possible. Okay, because if you see in this expansion, every term will be like this. Every term in this, tell me what every term will look like in this one. Like if you have 2x minus 5y power 16. So what you can say? For example, you can consider this as A and you can consider this as B. So this is same as A plus B power 16. In this, what is the kth term? In this, every term is like this. If you notice, binomial theorem. So every term will be like this. A power k, B power 16 minus k, 16ck. Every term will be like this. Okay. So I can say that every term is basically, if you notice, every term is something like this. 16ck, A power k, A is 2x. A is 2x. So that is like 2x power k. B power 16 minus k. B is minus 5y power 16 minus k. Every term is like this. And what you want? So ultimately I can say that this is the point. 16ck, 2x power k minus 5y power 16 minus k. Okay. And what the question is asking? The question is asking coefficient of x power 7, y power 9. So we want x power 7. What we want? We want k equal to 7. We want k equal to 7. This is what we want. Okay, we want k equal to 7. So let's put k equal to 7. So if you put k equal to 7, that will be 2x power 7 minus 5y. 16 minus 7, that will be 9. 16c 7. Okay, from here you can easily say that x power 7, y power 9, the coefficient will be 16c 7 multiplied by 2 power 7 multiplied by minus 5 power 9. Minus 5 power 9. Minus 5 power 9. This is your answer. Okay, so your coefficient will be, the coefficient you are looking for, this will be the answer. This is your answer. Is this point clear? 16C7, 2 power 7 minus 5 power 9. This is your final answer. You can check it. Okay, so this is another simple question. Now let's move on. What about this question? Question number 16. When I go to cream, okay, maybe some ice cream parlor or something, I order 4 scoops of ice cream out of 10 possible flavors. 10 flavors are there. I want total 4 scoops. I can get more than 1 scoop of the same flavor. Which problem is this? Which template is this? DODB, IODB, IOIB, DOIB. This template, which template is this? This is your IODB template. This is your IODB template. If you remember, this is your combination with repetition. If you remember, this is your star bar. You can call it star bar. You can call it combination with repetition. Combination with the repetition. Combination with repetition. So you can call it whatever you want to call it. The point is, who are the bars here? Tell me, who are the boxes here? These flavors are the boxes. Ice cream flavor 1, flavor 2, flavor 3. How many flavors? 10 flavors are there. These 10 flavors are the boxes. These 10 flavors, these are the boxes. Okay, total how many I want? I want 4. Total I want 4. These are the boundaries. Remember, total I want 4. Means, for example, I can take 2 here, 0 here, 1 here, everything 0. And then I can take 1 here. Then I can take 1 here. So this total I want equal to 4. This total should be equal to 4. So very simple, I can say how many bars you have? Total 10 boxes. So I can say total 9 bars are there. And these are the total 4 stars. So your answer will be 13C4, or I can say 13C9. This star bar has become your favorite or not? Star bar template. I hope you are finding this very interesting. This star bar problem is really very interesting. You will not get bored of it. Okay, this is not boring. Anything else can be boring. Product rule can be boring. Permutation combination can be boring. But this star bar is never boring. You will always find this interesting, that yeah, this is like you are using the star bar template, because this star bar means total 7 problems, 1 solution. Okay, you know, there is a ad, 5 problems, 1 solution. Aishwarya Rai does some ad, 5 problem, 1 solution, something like that. Star bar is saying 7 problems, 1 solution. That is star bar. So this star bar is very, I can say, very interesting problem. Okay, so let's move on. So let's see this question. Question number 17. How many ways I can buy 24 donuts if there are 8 different flavors? Again 8 different flavors. Total you want 24. Okay, total 8 different flavors are there, and you want total 24. Which template is this? Which template? Again your IODB. Again your star bar. Again your favorite star bar. IODB template star bar. Your favorite star bar. So tell me, you have total 8 different flavors. Flavor 1, flavor 2, and so on, flavor 8. These are your boxes. And you want total 24. You want total 24 you want. Total 24 you want. Okay, this total, if you see this total, this summation must be equal to 24. So here, 8 boxes means total 7 boundaries you need. Right? Total 7 boundaries you need. And these are the stars. So your answer is going to be, so final answer, what that will be? Final answer will be 24 plus 7, C7. 31, C7. This is your answer. Okay. Simple. Again, very simple question. This is your question number 18. Question number 18. Let's see. I pick a random 5-digit number. I pick a random 5-digit number I am picking. what the probability that digits are increasing could be repeating order. Okay, interesting question. So let's see. Which template is this? See, this is your probability. The question is asking for probability. So the answer will be total favorable minus total, right? Something like this. Favorable cases divided by total cases. This is your probability. Favorable cases divided by total cases. This is the probability. So can you find total cases? Can you find favorable cases? And for favorable cases, this template is your IODB template. Why this is IODB template? Because it could be repeating. This is like non-decreasing digits. Non-decreasing digits. So this is your favorite template, IODB template. Can you find it? So tell me how many total cases in this question? What is the number of total cases? Total cases. You are randomly selecting 5-digit number. How many 5-digit numbers are there? You are randomly selecting 5-digit number. How many 5-digit number are there? You are randomly selecting 5-digit number. 5-digit number you are selecting randomly. So how many? For the first position, 9 choices. Here 10 choices. Here 10 choices. Here 10 choices. Here 10 choices. So that is 9 into 10 to the power 4. This is your total number of cases. And what are the favorable cases? What are the favorable cases? Means desired cases. What are the desired cases? Desired cases are you want 5-digit increasing number. In the increasing number, this case we have already seen. If you remember, today we have seen this. Agree? This question, the same question we have seen already. 5-digit increasing number you want. In the increasing number, can you use 0? In the increasing number, can you use 0? You cannot use 0. So who are your boxes? These are the boxes. These are the boxes. And so these are your boxes. So I can say total 8 bars are there. 8 bars. And total how many stars? This summation should be equal to 5. This summation should be equal to 5. So very simple. So remember, I can simply say that total 8 bars are there. Total 8 bars. You have total 8 bars and total 5 stars. Total 5 stars. So your answer will be 13C5. Your final answer will be what? Your final answer will be the probability the question is asking. That will be 13C5 divided by 10 multiplied by 9 power 5. You can just leave it here. Just leave it here. You don't have to calculate. You can just leave it here. Okay, so I hope this, that is 9 power 4. Sorry, that is 9 into 10 to the power 4. That is 9 into 10 to the power 4, 13C5. Okay, this is your answer. You can see 13C5 divided by 9 into 10 to the power 4. So simple question, we have done it. In the same question, if I make this variation decreasing, now what will be the answer? In the same question, if I make this variation decreasing, now the answer will be total is, the total is same, 9 into 10 to the power 4. The total is same. Okay, but on here, here what you will write? Here basically you will write 14C5 minus 1. This minus 1 you are doing for all 0. For all 0 you are doing this minus 1. So this divided by this. This will be your answer. Okay, let's move on. Tell me the answer for this one. What is the answer? I have 5 identical rings that I want to wear at once. Okay, how many ways? What this at once means? I want to wear at once. What this means? I want to wear at once means you are not wearing one after one. You are not wearing like this. First I wear, then I wear another, then I wear, then I wear, then I wear. Okay, you are not doing like that. You are wearing all of them at once. Okay. How many ways can I put them on my 10 fingers if each ring must go on a different finger? Which template is this? Which template is this? See, every ring is going on a different finger. This is your simple template. No template is required. In this question, no template is required. You can simply say that you have total 5 rings are there, and you want to put them on 10 fingers. So just choose 5 fingers. That's it. See, very simple. 10 fingers are there. One finger, I can say one ring should go on one different finger. Means 2 rings cannot go on the same finger. 2 rings cannot go on the same finger. So just select 5 fingers from the 10 fingers. Select 5 fingers. Basically, select 5 fingers. Just select 5 fingers. That's it. Select 5 fingers. All are identical. So just put it. So your answer will be what? Answer will be 10C5. Is this point clear? Is this point clear? See, there are total 10 fingers and you want to put 5 identical rings at once. And one finger cannot have more than one ring. 2 rings cannot go on the same finger. Okay, one finger can have at most one ring. So I can simply say total 10 fingers are there. You can select 5 fingers. Just select 5 fingers. And in those 5 fingers, you can put the 5 identical rings. Because these are identical rings, so you can put it only one way. Yes or no? Once I select 5 fingers, if I select these 5 fingers, then what I can do? I can just put the ring in only one way. So very simple. Because all the rings are identical. So your answer will be 10C5. Let's move on. What about this one? Question number 21. How many solutions are there for this equation x1 plus x2 plus x3, where all of them are greater than equal to 0? Where all of them are greater than equal to 0, but x1 is greater than equal to 4. But x1 is greater than equal to 4. This is your star bar problem. All are greater than equal to 0, but x1 is greater than equal to 4. Is it even possible? Like, for example, x1 plus x2 plus x3. This should be equal to 1. This should be equal to 1. This should be equal to 1. This is greater than equal to, sorry, this is greater than equal to 4. This is greater than equal to 0. This is greater than equal to 0. Is this even possible? This type of solution, is this even possible? Is this solution possible for this equation? For this equation, total must be 1. Total must be 1. See, total must be 1. The summation must be 1. The summation must be 1, but this value must be greater than equal to 4. This value must be greater than equal to 0. This value must be greater than equal to 0. So no solution possible, right? Yes or no? For this equation, there is no solution possible. There is no solution possible. There is no solution possible. So simply, how many solutions are there? So the number of solutions will be 0. No solution possible means number of solutions 0. Number of solutions 0. Is this point clear? Let me know. So simple, very simple. In this question, number of solution will be 0. So I think in this question, there might be some mistake maybe. Okay, so see, the solution is given according to 11. Agree? The solution that is given in the PDF, the solution that is given according to 11. Let's solve the same question if I put 11 here. Now let's solve. Okay, let's solve the same question, but I'm putting 11 here. Now this is equal to 11. This is what I'm doing. Let's solve the same question, but I am putting 11 here. Now you tell me. So here now you can see This is your x1 plus x2 plus x3. This should be equal to 11, but this value must be greater than equal to 4. This value greater than equal to 0. This value greater than equal to 0. So it's like Santa has 11 chocolates. Okay, you have Santa has 11 chocolates, 11 identical chocolates, 11 same chocolates. Okay, so what you will do? This child, to this child, we want to give at least 4 chocolate we want to give him. Okay, to this child, any number of chocolates, means I can say greater than equal to 0. To this child, any number of chocolates. So what the first thing we will do? Tell me, what the first thing this Santa will do? All the chocolates are same. All the chocolates are already same. All the chocolates are same. This child is saying that give me at least 4. So just directly give him 4. Give him 4 chocolates directly. So what your new equation will be? This will be your new equation, right? Your new equation. Your new equation, because from these you will directly give 4 to him. You will directly give 4 chocolates. 4 chocolates you will directly give. Now the new equation that you have, this type of new equation you have, where now everything is greater than equal to 0. Now everything is greater than equal to 0. And how many chocolates are remaining? 4 chocolates are already gone. How many chocolates remaining? 7 chocolates remaining. So here very simple. So total how many bars? Total 2 bars, you can see. So total 2 bars, 7 stars. Your answer will be 9C2. 9C2. In this PDF, what is the answer that is given? That is same, 9C2. 9C2. Okay, 9C2 is same as 9C7. Both are 7. Both are same. So remember, this is a simple point. Actually, according, the answer is given according to this question. Is this point clear? The answer is given according to this question. According to this question, the answer is given. Okay, let's move on now. So tell me the answer for this one. Question number 22. Suppose that Alice chooses 4 distinct numbers from numbers 1 to 10. Same thing Bob does. Bob also chooses 4 numbers. What is the probability they choose at least one number in common? At least one. Whenever you see this at least one, what will come to your mind? Whenever you see this at least one, complement rule, right? Again, this complement rule will come to your mind, right? Very simple. Just use the complement rule. So what your answer will be? The question is asking for probability. But anyway, first let's find out what are the total cases then. The question is asking for probability. What are the total cases? What are the total cases? Just count the total cases. Alice is choosing 4 distinct numbers and Bob is choosing 4 distinct numbers. Okay, Alice, Bob, they are choosing 4 distinct numbers. So what are the total number of cases? See, Alice is choosing 4 distinct numbers. 10C4, Alice. Alice is choosing. This is for Alice. And what about Bob? Bob is also choosing 4 distinct numbers. Same Bob is doing. So I can say total. What is total? Total is this. Agree? This is the total number of cases. Simple. Both of them are choosing 4 numbers. Now, what is the desirable cases? Now, we want these cases where they select at least one common. Alice, Bob have at least one common. Alice, Bob have at least one common. Have at least one common. One digit common. Or one number common, sorry. One number common. They are selecting 4 numbers. So they have one number common. So that will be equal to, that will be total minus not common. Nothing common. Total you already know. Total you already know. That is your 10C4 into 10C4. 10C4 power 2. That is your 10C4 power 2. That you already know. When nothing is common, then what? See, then now this. See, Alice can choose anything. These many choices for Alice. Alice can choose any four number. Alice can choose any four number. And any four number Alice can choose. Now, Bob has how many numbers to select from? Nothing common, nothing common. Alice can choose any four numbers. Now from the remaining, Bob has to choose. From the remaining, Bob has to choose. From the remaining, Bob has to choose. So your answer will be what? Tell me. Final answer. What your final answer will be? That will be 10C4 power 2. 10C4 power 2 minus 10C4 multiplied by 6C4 divided by 10C4 power 2. This is your final answer. Is this clear? Because the question is asking for probability. So this is your answer. Simple. You can just solve it. You will get this. Okay. If you divide this, then it will be like 1 minus this divided by 10C4. So if you simplify, you will get this. Now let's move on. Let's see this question number 23. What will be the answer? How many ways are there to distribute 8 cards out of 52 card in 52 card deck to 3 people if some people can receive no card at all? See, please understand the question. The question is saying there are total 52 cards deck. Okay. From these 52 cards deck, what you do? You only want 8 cards. How many cards I want to distribute? Do I want to distribute all the 52? Tell me, how many I want to distribute to these 3 people? There are 3 people. There are 3 people A, B, C. These are the 3 people. These are the 3 people. So remember, the question is asking distribute 8 cards. Distribute 8 cards. So first you select 8 cards. First you select 8 cards from the 52 cards. First you select 8 cards. Now these 8 cards you distribute here. You distribute here. These 8 cards you give to these people. You give to these people. Anyone can get any number of cards. Anyone can get any number of cards. Remember, this is already given. Some people can receive none card at all. So anyone can get any number of cards. So your answer will be what? First you select from 52. First you select 8 cards. First you do this. First you select 8 cards. Agree? Agree with me? Because we want to distribute 8 cards out of 52 card deck. So you have 52 cards in your deck. From those, first you select 8 cards. Now, once you have these 8 cards, each card has how many choices? Once you have these 8 cards, each card has how many choices? Each card has 3 choices. Either it can go to A, or it can go to B, or it can go to C. Each card has 3 choices. Each card has 3 choices. Is it possible that from these 8 cards, some card does not go to anyone? Is it possible? From these 8 cards, some card does not go to anyone. No, that is not possible because we want to distribute these 8 cards to these 3 people. So for example, if you don't give anything to C, if you don't give anything to B, then everything will go to A. If you don't give anything to A, if you don't give anything to C, then everything will go to B. So every card has 3 choices. Okay, so remember every card has 3 choices. 3 into and so on 3. Because every card has 3 choices. This will be your 3 power 8. Why? Because every card has 3 choices. Because every card has 3 choices. So your final answer will be 52C8 multiplied by 3 power 8. This will be your final answer. Did you understand? Please tell me. Please tell me, did you understand? Okay. So simple. Now let's move on. Tell me the answer for this one. How many positive integers less than 10,000 have summation equal to 9? Have summation equal to 9. How many positive integers less than 10,000 have summation equal to 9? See, very simple. You want summation equal to 9. You want summation equal to 9. So what you can do? You can just maximum how many digits can be there? You want less than 10,000, less than 10,000. So maximum 4 digit you can have. Maximum 4 digit you can have. Maximum 4 digits you can have. Okay. And minimum, how many digits you can have? Minimum. How many digits you can have? Minimum 1 digit you can have. Minimum 1 digit you can have, right? Okay. So, but something interesting here. Should I count 1 digit separately, 2 digits separately, 3 digits separately, 4 digits separately? Should I count like this? Should I count like this? 1 digit separately, 2 digits separately, 3 digits separately, something like this. Should I do that? I can do that. I can do that. Okay, so let's do that. Let's start, because that is the first thing that will come to your mind. Agree? Do you agree with me? When you see this question in the exam for the first time, in the GATE exam, when you see this question for the first time, what is the first thing that will come to your mind? Which method will come to your mind? This method will come. 1 digit, 2 digit, 3 digit, 4 digit. That method will come to your mind. So let's use that. Okay, so let's solve it using the method 1. Method 1 is by case. Okay, so how many 1 digit? That is actually very easy. How many 1 digit? What is the answer? That is only 1. Okay, only one way. Only one way total, and that is your 9. Okay, your number will be equal to 9. Your number will be equal to 9. But there is only one way, right? There is only one way. And that number will be 9, because the summation should be equal to 9. Okay, how many 2 digit? 2 digit A, B. 2 digit A, B. 2 digit A, B. What I want? I want A plus B equal to 9. Which template is this? Which template is this? A plus B equal to 9. When you see this, which template is this? Isn't it IODB? This is your IODB template. The summation should be equal to 9. This is your IODB template, right? The summation should be equal to 9. So this is your IODB template. Agree? This is your equation. No negative integer solution equation. This is your integer solution equation. So this is your IODB template. Now you tell me, but there is a catch here. What is that? So can I say 2 digit? 2 digit A plus B. 2 digit, that is AB. A plus B equal to 9. So can I say from here, can I say that 9 stars, 1 bar? So can I say answer will be 10C1? Can I say answer will be 10C1? Can I say that? Can I say that? Can I say that? No, this is wrong. No, this is a wrong. This is a wrong. And where did we do something wrong? Where did we do something wrong? Tell me. See, we did something wrong because this A should not be 0. This A cannot be 0. Or I can say this A should be greater than or equal to 1. This A should be greater than or equal to 1. This B can be anything. This B can be anything. Is this point clear? Is this point clear? This A cannot be 0 because we want 2 digit. So A cannot be 0. So now you solve it. Now what you are getting? So it's like the Santa example, the same Santa example. The same Santa example. So what you will do? What is the first thing you will do? First you will give 1 chocolate to, tell me, what you will do first? From here, what you will do? First you will give 1 chocolate to A. Agree? First you will give 1 chocolate to A. Just give directly 1 chocolate to A. Total 9 chocolates you have. Total 9 same chocolates, identical chocolates you have. Total 9 identical, or I can say total 9 identical chocolates you have. So give 1 chocolate to A. What is the next new equation? The new equation is like this. A dash plus B dash equal to how many chocolates are remaining? How many chocolates remaining? 8 chocolates remaining. 8 chocolates. Now you can give it anything, and now you can give it anything. Now your answer will be what? Now this is the equation you got. That's it. This is the equation you got. Means now you got this equation. Now basically now you got this equation. A new equation you got. A new equation. Now you got this new equation. This new equation you got. Okay, and in this new equation, you have total 8 stars, 1 bar. So the answer will be 9C1. Is this understood? 9C1, that is your 9. Interesting, simple. This is not complicated. This is very simple. Now can you find the 3-digit? Now can you find 3-digit? 3-digit means ABC. Means A plus B plus C equal to 9. Again, this is greater than equal to 1. This is greater than equal to 0. This is greater than equal to 0. Remember, this is greater than equal to 1. Okay. So here, what your answer will be? You can give 1 chocolate directly to A. So if you give 1 chocolate directly to A, 1 chocolate you directly give to A, only 8 chocolate will be remaining. 8 chocolate will be remaining. Now this is greater than equal to 0. This is greater than equal to 0. This is greater than equal to 0. Now you can say total how many bars are there? Total 2 bars and total 8 stars. So answer will be 10C2 and that is your 45. Is this clear? Finally, how many 4-digit? 4-digit A, B, C, D. Remember that this should be greater than equal to 0. Greater than equal to 1. So again, the same thing. The summation should be equal to 9. The summation should be equal to 9. This value should be greater than equal to 1. This should be greater than equal to 0. This should be greater than equal to 0. Again, the same scenario you will do. You can create a new equation. You can create a new equation because 1 chocolate you can directly give to this person. You can directly give to one to this A. Now everyone is greater than equal to 0. Everyone is greater than equal to 0. So now you have 8 stars, 3 bars, C3. That is your 11C3. Your final answer will be what? Tell me what is your final answer? So your answer will be 1-digit plus 2-digit plus 3-digit plus 4-digit. 1-digit, how many? Only 1. 2-digit, how many? What was 2-digit? How many were there? 9. 3-digit were 45 and 4-digit were 11C3. You can calculate. You can calculate. This is your final answer. Is this? So can you do this type of questions where the question is asking for summation of digit equal to something? So this type of questions are also which template? So can you note that summation of digit equal to, like for example, number. Okay, this template. What is this template? Tell me. Summation of digit. Summation of digits is equal to some number. For example, some number. For example, I can say is equal to 14. Summation of digit equal to 14. Which template is this? I am just asking which template is this? This summation of digit equal to something. This is your IODB template. This is your IODB template. Another template, another problem, IODB template. Can you see IODB template covers how much area? Can you see how much area IODB template covers? Like this type of question if comes, okay, this type of question if comes in the exam, summation of digits equal to something, that is also IODB template. Now, let me give you one method number 2 also. Actually, method number 1 we have seen, but let me give you method number 2 also. What is that? So you can directly consider A, B, C, D. You can directly consider like this. Is equal to 9. Is equal to 9. You can directly consider A plus B plus C plus D equal to 9. Because maximum 4 digits can be there. Agree with me? Agree with me that maximum 4 digits can be there. You agree? Maximum 4 digits can be there. Okay, maximum 4 digits can be there. Let's assume these digits are ABCD. Let's assume these digits are ABCD. So you can directly see A plus B plus C plus D equal to 9. Now you will be thinking, what you are thinking now? Sir, this will cover 4-digit cases, but how will it cover 3-digit cases? How will it cover 2-digit cases? Agree? Are you thinking? I am saying you directly do A plus B plus C plus D equal to 9. You directly do this. Now you are thinking that how it will cover 3-digit cases. How it will cover 2-digit cases. That is interesting here. See, what you can do, just make sure that everything is greater than equal to 0. Now tell me, how 3-digit cases are considered here. Just tell me. You make everything greater than equal to 0. Now, how 3-digit cases are considered here? Tell me, anyone? How 3-digit cases are considered here? By making this a 0. Yes or no? By making this a 0, you can consider 3-digit cases. If you want to consider 3-digit cases, then what you need to do? 3-digit cases means a equal to 0. 3-digit cases means a equal to 0. And if a comma b equal to 0, if a equal to 0, b equal to 0, which cases you have considered? If a equal to 0, b equal to 0, then 2-digit cases you have considered. And if ABC are 0, then which case you have considered? If ABC are 0, then 1-digit case you have considered. So did you notice? This is something, I can say, just a smart trick. You can call it a smart trick. But the method number 1 that will come to your mind, remember, in the GATE exam, in any exam, in those 3 hours, the first method that will come to your mind will be method number 1. Okay. Don't underestimate the power of first approach that will come to your mind. Remember this point. See, this is a smart approach, I can say. This approach, I can call it intelligent approach, or I can say smart approach. Okay, something smart we are doing. But, will this come to your mind in the exam? This method will come to your mind, or method number 1 will come to your mind? With the first approach that will come to your mind, that came to your mind when you saw this question, that is method number 1. This is the reason. First, we have seen method number 1. Now I'm telling you this smart approach, something smart. What you can do? You can just make this equation a plus b plus c plus d equal to 9, and everything is greater than equal to 0. Now remember, we have considered everything. Remember, 3-digit cases we have considered. You can make a equal to 0. See, a equal to 0, 3-digit cases you will get. AB equal to 0, you will get 2-digit cases. ABC equal to 0, you will get 1-digit cases. So all the cases you are getting. Do you agree with me? In this method too, you are getting all the cases. Agree or not? This is also greater than equal to 0. Every case you are getting. So your answer will be what? Tell me. 9 plus 3C3. That will be 12C3. You can check. This will be your answer. Can you check? This method 2 answer is the same as method number 1 answer. Method 2 answer is that same as method number 1 answer. Yes, you can check. The idea is simple. See, the idea is actually simple. The idea is this. A, B, C, D. Okay, the idea is this. That A equal to 0. When A equal to 0, then in this case, basically you are getting 3-digit number. And when A, B both are 0, then you are getting 2-digit number. And when A, B, C all are 0, then you are getting 1-digit number. Just make sure that A plus B plus C plus D equal to 9. So this is your something smart. You can keep it in mind. This approach also you can keep in mind. Okay. Is this point clear? You can keep this approach also in mind. You can understand method number 1 also, method number 2 also, both of them. Both are interesting. Method number 1 is also very interesting, and method number 2 is also very good. Okay, so you can use any of them. That is your choice. Use any of them. I have told you both of them. Okay. Let's see this question. Tell me the answer. Question number 25. I am planting 15 trees, 5 willow trees and 10 fir trees. Okay. How many ways can I do if no 2 willow trees are next to each other? No 2 people together. This template have we seen? No 2 people together. Have we seen this template? Yes, we have seen this template. 2 people, no 2 people together. So, something like this. 2 people never together. Some people never, I can say few people never together. This template actually we have seen. What you will do, very simple. Willows should not be together. Okay, you have 5 willow tree and you have 9 fir tree. And remember, 2 willow cannot be together. No 2 willow together. No 2 W together. So the answer will be what? First you arrange the fir trees. How many ways to arrange the fir trees? How many ways? Tell me. FF. How many ways to arrange fir trees? Only one way. Only one way. Only one way. First you put them. First you put all the fir trees. Only one way. Now in the gaps, how many gaps are there? Total 10 gaps. In 10 gaps, you put willow tree. In these 10 gaps, you select 5 for willow. Means select 5 gaps from 10 for willow tree for W. Okay, is this point clear? Now you might be thinking, some of you might be thinking, sir, these are distinct. Should I consider them identical or should I consider them distinct? Sorry, 10 fir trees are there. Okay, 10 fir trees are there. Your total 10 fir tree. So how many? There will be total 11 gaps. Total 11 gaps. So very simple. This is your answer. Now you tell me, when you read this question, what will come to your mind? Will you consider willow tree and fir tree, the 5 willow tree, will you consider them distinct? The question maker's intention. This is question maker's intention. When you read this question, what is coming to your mind? What do you think? What is the intention of the question maker? Just tell me. If you are the question maker, if you write this question, if you create this question, what do you think? What is your intention? You are thinking that willow tree are identical and fir tree are identical, right? Yes or no? Is this point clear? You are thinking that fir tree or the 5 willow tree, they are identical. You have 5 willow tree, and similarly 10 fir tree, they are also identical. It's like reading the question maker's mind. Sometimes you need to do it in the GATE exam also. In the GATE exam also, there are some questions where you have to read the question maker's mind. Are you getting my point? Anyone has any doubt in this question? Please tell me. Do you have any doubt? Read question maker's mind. Okay, so here the question maker is thinking that these willow tree, these are identical, and these fir tree, these are also identical. So your answer will be 11C5. Okay, simple. What about this question? Tell me. How many ways we can deal 4 cards hands from a deck of 16 different cards if the hands go to indistinguishable piles? Which template is this? Which template is this? Identical piles. These are the identical boxes. These are the identical boxes. Identical boxes. So this template is what? This is your DOIB. This is your DOIB template, right? Agree? This is your DOIB template. Because you have identical boxes. Your boxes are identical. So your answer will be what? See, total 16 different cards are there. It is already given. It is already given 16 distinct cards are there. See, this is already given. 16 different cards are, this is already given. Now, from these, first you will select how many? Okay, tell me, first you will select how many? See, you need 4 card hand. So first you will select 12. Agree with me? So first you select 12. First you select 12. Now. These distinct cards you have. These distinct cards you have. And these you need to put in 3 rooms. 3 identical rooms. Identical rooms. 3 identical rooms. So 3 identical rooms. And in each room you need to put 4 cards. In each room you need to put 4 cards. So tell me the answer. First you tell me. Here answer will be what? Like in this second step. See, first you select from 16, you select 12. This is the one thing you need to do. This is the one thing you need to do. First you select 12 from 16. Select 12 from 16. This is the one thing you need to do. The second thing, what is that? The second thing is 4, 4, 4. So the answer here, what will be the answer? See, that is 12C4 multiplied by 8C4 multiplied by 4C4 divided by whom? Tell me, divided by whom? Divided by 3 factorial. Divided by 3 factorial. 3 factorial because 4, 4, 4. Because 4, 4, 4. Because of this 3 factorial. So your final answer will be, if you solve it, what you will get? 12C4, 8C4, 4C4. If you solve it, you will get 12 factorial divided by 4 factorial power 3 into 3 factorial. This is your final answer. Is this point clear? See the final answer, you can check it. 12C2. If the piles are distinguishable, how many ways to deal 3 4-hand card from a deck of you see, you simplify this, what you are going to get? If you simplify this, what you are going to get? Will you get the same? This same value are you getting? If you simplify this, are you getting the same value? See, this I can write 16C4 multiplied by 12 factorial divided by 4 factorial power 3, 3 factorial. Are you getting the same? Is this same as this? Here also you have 16C4. You got 16C4. Okay, no problem. Next. Yeah, same. This is the same answer that you are getting. We are also getting the same answer. Remember, if you call it X, this is also X. This is not a different answer. Is this point clear? You can check. Both are same. Remember this point. 16C12, that is same as 16C4. Is this point clear? The answers are not different. This is the trick they will play in the exam, in the GATE exam, in the MSQ question, in the MCQ question. Agree with me? They can give you this, no problem. See, this answer is also same as our answer. We are also getting the same answer. We are also getting the same answer. Is this point clear? This same answer we are getting. So you can check it out. Our answer is also X and this answer is also X. So, and this simple point you already know, NCR equal to NC n minus R. Okay, I hope everything is clear so far. All the questions so far, are they clear? Please tell me. Okay. So let's see this one. What is the answer for this question? How many ways? Question number 27. How many ways we can put 5 distinct balls in 20 identical beans? This is very interesting question. Very interesting question. How many ways can we put 5 distinct balls in 20 identical beans? Anyone want to tell me the answer? See, you have 5 distinct balls. You have 5 different balls. 5 distinct balls we have, and 20 identical beans, 20 identical rooms. It's like this. It's like this. There are total 5 friends. There are total 5 friends. And they go to a hotel. In this hotel, there are 20 same rooms. First you tell me, is this data misleading? Can I say, whatever answer you will get here, that same answer you will get if 5 friends in this hotel, if you have 5 rooms. Please understand the trick. In this hotel, if you have 5 rooms, then also you will get the same answer. Because remember, rooms are same. So does it matter? You have 20 same room, 40 same room, 80 same room. Does it matter? Please tell me. All the rooms are same. Maximum how many rooms you can use? All the rooms are same. Maximum how many rooms you can use? Tell me. Maximum 5 rooms you can use. Maximum 5 rooms you can use. So in this question, can you notice this 20, the data is given 20 same rooms, 20 identical rooms. That is to confuse. So that some students will get confused and they will either give a wrong answer or they will leave the question. Can you notice? The question is playing some trick. Because remember, 20 same rooms, same. So does it matter you have 20, 40? Does it matter? Tell me. Even if you have 1,000 same room, does it matter? Will the answer change? The answer will not same. The answer will be same. You will get the same answer. Because anyway, you have same room. Anyway, you have same room. For example, see, anyway, you have same room. R, like this. Okay. See, let's assume that you have same room. Let's assume you have same room. Let's assume. Now notice. These 5 friends, whether they use these 5 rooms or they use these 5 rooms, does it matter? Is it different? These 5 friends go to these 5 rooms. These 5 friends, they are going to these 5 rooms, or they are going to these 5 rooms. These 5 rooms. Is it different? No, all the rooms are same. So anyway, you can use maximum, you can use 5 rooms. I can use maximum 5 rooms. I don't even care about these 2 rooms. These extra rooms, I don't care. These extra rooms are irrelevant. Agree? This trick is interesting or not? Some students will definitely make mistake. Some people, they will definitely make mistake because they will be thinking, oh, 20 rooms is given, so I should use this data. Some data is given in the question, I should use it. This data is given, so definitely I should use it. Agree or not? This is a mentality. When we read a question, we want to use the data that is given in the question. In the question, if they give you some data, you definitely want to use it. But in this question, you can notice identical rooms, 20 identical rooms. That is a trick. That is a trick because anyway, you are not going to use. These rooms are anyway irrelevant. These rooms are anyway irrelevant. I hope this point is clear. So your final question, tell me what your final question is. So what is the question now? The question is simple. 5 friends going to 5 same rooms. Agree? 5 friends going to 5 same rooms. This is which template? Which template? This is your DOIB template. How to solve it? This is your DOIB template. How to solve it? In a systematic procedure, in a systematic way. So let's solve it. So the case number 1, use only one room. Use only one room. If I use only one room, then how many ways? Go in a systematic way. Use only one room. So there is only one way because all these people will be together. There are 5 friends. Let's call them A, B, C, D, E. Let's call them A, B, C, D. There is only one way because all these will be together. A, B, C, D, E. If this is a haunted movie, then this is a smart move, right? If this movie is a haunted movie, let's assume this is a haunted movie. Then what you will say? If you are watching this movie, what you will say? Then you will say it is a smart move that they are all together. Okay, so you can say they are all together. They are only using one room. So only one way. Why one way? Why not 5? Can I say they are using one room? So there are 5 ways. Can I say they are using one room? So can I say there are 5 ways because there are 5 rooms? There are 5 rooms. So can I say there are 5 ways? No, all are same rooms. All the rooms are same. So you can use any room. All the rooms are same. So that is the reason only one way. What the case 2? Use 2 rooms. Use 2 rooms. What are the cases? If I use 2 rooms, either I can do, for example, 4,1. I can use this distribution. I can say 4,1 or I can say 3,2. Anything else? Anything else possible? No, nothing else is possible. Can I say, oh, 2,3. Is this different or same? They are different or same? They are same because rooms are same. Rooms are same. All the rooms are same. So tell me here. Here it means 4 people together, 1 people is going separate. Okay, 4 people together, one person going separate. This person will die, right? In the haunted movie. If this movie is the haunted movie, then this person is gone. He is the smart. He is being smart. Okay, you will say that he is being smart. So in this haunted movie, he is gone. So anyway, how many ways? 4 people together, one person going separate. You can decide who is going separate. You can decide who is going separate. From 5 people, who is going separate, you can decide. So there are 5 ways. What about this one? 2% together, 3 people together. 2 people together, 3 people together. So that is, just decide who 2 people are together. Decide who 2 people are together. Who 2 people are together. Automatically the remaining 3 people will be together. Automatically the remaining 3 people will be together. This is already one. This is already one. So here you have total 10 ways. What about case 3? Case 3 means use 3 rooms. Use 3 rooms. If you are using 3 rooms, then what is happening? What are the cases possible? 311 is possible. 311 possible. What else is possible? 221 possible. Anything else? No. These are possible. Here what you can decide. See, here you can decide which 3 people are together. Which 3 people are together. From 5 friends are there. A, B, C, D, E. From 5, you decide which 3 people are together. From 5 you select 3, they will be together. Automatically the remaining 2 people will go separate. Okay, so just decide which 3 are together. Automatically the remaining 2 people will go separate automatically. So here also this is same as 5C2, that is also 10 way. What is another way to solve it? What is another way to, either you can solve like this. What is another way to solve it? The another way to solve it, that is 5C3 multiplied by 2C1 multiplied by 1C1 divided by 2 factorial. 2 factorial because of this. 2 factorial because of this. Again, you will get the same answer. Again, you will get the same answer. And what about this one? What about the answer for this? This will be like 5C2 multiplied by 3C2 multiplied by 1C1 divided by 2 factorial. Is this point clear? These many ways. What is the answer here? Calculate. What is this value? Anyone? What is this value? This value. See, this is 10 multiplied by 3 divided by 2. So this is 15, right? This is 15 ways. Okay. So next, what is the case for? Use 4 rooms. Use 4 rooms. If you are using 4 rooms, the only possibility is this. Agree? If you are using 4 rooms, the only possibility is this. So select who 2 are together. From 5 friends, there are 5 friends. You choose which 2 are together. You choose which 2 are together. Automatically, the remaining 3 people will go separate. Automatically, the remaining 3 friends, they will go in a separate rooms. So here also 10. What is the next? What is the last case? What is the case 5? That is it. Use 5 rooms. Use all the 5 rooms. There is only one way. All people, they will go separate. There is only one way. Your final answer is what? Tell me your final answer. What is your answer? That will be, you can just add all of them. You can, from the beginning, 1 plus 5 plus 10, you can add 1 plus 5 plus 10 plus 10 plus 15 plus 10 plus 1. This is your final answer. Tell me what is the answer? 10, 10, 10. So that is 30, 30 and 20. So that is 52. Your final answer will be 52. Is this point clear? That the answer is 52. Simple. The answer is 52. Okay. The remaining questions, only 3 questions are remaining. 28, 29, 30. Only 3 questions are remaining. So either we will do later, or the solution you can check in the PDF. Okay. See, this is question number 28. Already solution is, solution is already given here. Solution is already given here. You can check. This is your question number 28 solution. And similarly, this is your question number 29. The solution is given. You can check it out. Okay. So anyway, anyone has any doubts so far? 3 questions are remaining. Question number 28, 29, 30. 3 questions are remaining. Don't worry about these 3 questions. We will solve. Don't worry. We will solve maybe tomorrow. Okay. Is this point clear? So Anish is asking, in the question number 25, is there any way to figure out if the tree are identical or not? No, there is no way. There is no way. I told you sometimes you have to read the question maker's mind. Anish, in the GATE exam, sometimes it happens. You have to read question maker's mind. There are multiple GATE questions. In the previous year, you can check. There are some questions where you have to read the question maker's mind. Most of the time, GATE questions, most of the time, 99% of the time, GATE questions are unambiguous. There is no ambiguity. But sometimes you have to read the question maker's mind. For example, if I read this question, then automatically it will come to my mind that willow trees are identical and fir trees are identical. So this is like reading question maker's mind. Okay, for example, see, Anis, just tell me this point. If I say 5 gulab jamun, in your mind, what is coming? Identical or distinct? I just mentioned 5 gulab jamun. I am saying 5 gulab jamun. What is coming to your mind? Identical is coming, right? Are you getting my point? What I'm saying? Sometimes you can read the question maker's mind. So here also, if I say, for example, 10 trees, if I say there are 10 willow trees, 10 sangwan trees, so identical will come to your mind. Agree? Is the point clear? So anyone has any other doubt? So far, anyone has any other doubt? Please let me know. Anyone has any other doubt? In these questions, total 27 questions we have seen. Anyone has any doubt in these 27 questions? The remaining 3 questions we will see in the next session. I will give you some more questions. Did you learn something new from this session? From this session, did you get to learn something new, like some new approaches, some new questions? Did you get some confidence in combinatorics? How to count, how to solve combinatorics questions? Are you getting some confidence? Okay. Okay. Thank you, everyone. I will give you more questions. Okay. I will provide you another practice set. I will provide you. And these 3 questions that are remaining, these we will see in the next session. Thank you.